Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Invert binary tree, Leetcode 226. In this problem, we are given the root of a binary tree and we have to invert the tree and return its root. Then in example 1, for the given binary tree, when we invert this tree, the root node stays the same, but we invert its children. That is, swap its children 2 and 7. So now 7 becomes a left child and 2 becomes a right child. And then we also apply the definition of inversion to the children as well. So now we invert the tree at node 7 as well. So node 7 had left child as 6 and right child as 9. But in the inverted tree, 9 becomes a left child and 6 becomes a right child. Similarly, for subtree with 2 as parent, we invert the left and right children. So 1 becomes a right child and 3 becomes a left child. And now we have performed all the inversions. So this will be our final output. Now the solution will be very similar to what we did in the example walkthrough. So we visit every node in the tree and for each node, swap its left and right children and then recursively apply the same process to its left and right subtrees. And since it involves recursion, we can use depth first search or DFS traversal here. And the base case will be when the root node is null. In that scenario, we cannot perform any swap as there are no children to swap. So now let's see this in action. Let's take the tree from example 1. We start at the root node with value 4. It has two children 2 and 7. So we swap them. And how will we swap them? We will just take backup of say left child, swap the left child with the right child and replace the right child with this temporary variable and perform the swap. So here we will take the backup of node 2 and swap node 7 with node 2 and set the right child on the root from the temporary variable. And now we will recursively process node 7's children as well. We can see that node 7 has two children 6 and 9. So we will swap them as well. Similarly for node 2 also we will do the same thing. So we will swap its children 1 and 3. So it becomes 3 and 1. Then we come to node 9. We swap its children but both of them are null so nothing will change. And when we go to these null nodes, our base case kicks in. So we return from there. And similarly for node 6, 3 and 1. And now we are done with all the nodes in the tree. So we have inverted the binary tree and now we can jump into the code part. If root is null, then we don't have to do anything. We will return null. Otherwise, we will swap the left and right children. So for that, we will temporarily store the left child of the current node in a variable temp and swap the left child with the right child and set the right child of the current node from the value stored in the temporary variable and recursively call the invert tree function on the left and right subtrees. And after both the subtrees have been inverted, we return the current root node. Now let's submit this code. Cool. Now in terms of time complexity, it will be O of n because we are going through each node in the tree only once. And in terms of space complexity, it will be O of h, where h is the height of the tree because the depth of our recursion will be same as height of the tree. And in the worst case, in case of a skewed tree, it will be again proportional to O of n. And also here is a fun fact about this problem. One of the creators of Homebrew once interviewed with Google and failed to solve this problem and later tweeted about it, which you can see on the screen. And he is still doing great today. So if you have failed to solve this problem in first go, don't worry, just keep practicing. Everything still turns out to be fine. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.